Hi, my name is Lars Nielsen. I'm a test engineer from Keysight Technologies. I'm here to give you an introduction to OpenTAP and how it can be used in relation to test composition and test automation. First, I'll go through OpenTAP and give an overview of the concept and the architecture. Then I will show you how it's used, present some UIs, and go through the workflow of developing a test and running it. Finally, I will show a demo of how a test can be created based on a real use case from composition all the way to presenting the results. So I'll start with giving an overview of OpenTAP. OpenTAP means open source test automation platform. It was developed and open sourced by Keysight. OpenTAP is a lightweight sequencing engine and uses a very modular approach where all the functionalities are provided as plugins. Through OpenTAP you can configure DUTs, SUTs, tools and much more, using the different concepts of instruments and test steps within OpenTAP. OpenTAP allows for quick development of plugins and fast creation of test plans. OpenTAP enables you to have automated control of all the tools and DUTs you might need. There are three main reasons for using OpenTAP for test automation: simplicity, scalability, and speed. The entry barrier is low and is focused on test automation, not trying to cover unrelated stuff. It's simple for programmers to develop the plugins using the SDK, for non-programmers when creating test plans using drag and drop, and for operators as the exposed details can be limited all the way down to a single start button. It's scalable due to highly modular structure and acting as the glue tying tools and DUTs together via test automation. Intellectual property can be encapsulated in plugins, such as IP related to the control of tools and DUTs. And it provides speed as it is optimized for manufacturing while also working for R&D usage. Keysight offers plugins as products such as analytics and timing analyzers. Here we see the architecture of OpenTAP. In the center we have OpenTAP as the core in test automation. Around it we see plugins created to provide various added functionalities to the system. We have user interfaces where the REST API is currently offered as a product by Keysight. Besides that, GUI and the command line interface. We have result listeners taking results and data published by test steps and moving them in databases or files. We have instrument plugins to interact with the various tools. We have test steps to configure tools or define flows of the test plan. And we have DUT plugins to control the entity on the test. This is all developed in C#.NET Core. Developer guides are provided which will allow you to have a plugin up and running within a few hours. The project is hosted on GitLab where OpenTAP core and open source plugins are available for the community. Now, the focus of this session is introduction and usage. So how does the user interact with it? The main point of interaction is the editor where the user composes test plans and configures test steps. Then there's the package manager for managing packages and plugins to be used for creating the test plans. And at Keysight we offer the desktop editor, the run explorer, timing analyzer and the results viewer as a product. But there's also the community edition of OpenTAP where the desktop editor is available. As I mentioned earlier, the core engine OpenTAP is released as open source and is available in a community edition. This and much more you can find on OpenTAP.io. There's also a big community supporting the development of the core and of OpenTAP plugins. We encourage you to join here at GitLab. With that we have an overview of what it is and how it's built. So let's go a bit more into how it is used. The main interaction point is the UIs. Here is the OpenTAP desktop UI. The main panel is the test plan panel where the test steps are composed into a test plan. The test steps are chosen from the test step panel, which shows the steps available provided by the installed plugins. Once added to the test plan, the steps can be configured via the settings panel. At the bottom you see the log panel where the output of the test steps are presented. And finally, down below the log panel is the resource bar where DUTs, instruments, result listeners can be configured. Another UI is the textual-based UI, which can be used in virtually any terminal. Via this, you can compose test plans and modify test steps settings. The test plan cannot be executed from here, but it can be done via the command line interface, for instance. A couple of things are needed before the test plan can be composed and executed. Naturally, you need to have a plan of what you want to test and how. Then you need plugins to control tools and what you are testing. And you need to decide if and how you want to store the results. Once these are in place, you're ready. First you install plugins, next you configure instruments, compose the test plan, and configure the result listener. Now you can run the plan, and finally view the results, for instance using Grafana, which I will show in a minute. Here we see an example of a use case where we want to create a test. The use case is: an emergency vehicle is transporting a patient to the hospital. The personnel in the vehicle wants to communicate the status to the personnel at the hospital, such that the personnel at the hospital can prepare or initiate treatment. There are communication equipment in both the hospital and in the vehicle. The equipment support functions to connect and transmit the status, live video, vital signs, and so on. The equipment can be controlled via the offered APIs. A test engineer will then write scripts to test the system capabilities in terms of functionality and performance. Now the same example, but handled using OpenTAP. We create plugins to control the ambulance and the hospital via test steps. Once we have the plugins, we can quickly create an OpenTAP plan by drag and dropping steps into the plan. With the plugins, it is also easy to fast create other test cases by reusing the steps. With those theoretical examples, let's take a look at how we do the process in practice. In our case, we want to run a test using the Hawkeye tool to test the connection between two endpoints. Once the test is done, we would like to save the results in the database, and finally, we want to visualize the results using Grafana. With Hawkeye, we can measure the end-to-end application layer network performance. Hawkeye has a server acting as both registration and command and control server, and the endpoints are clients that execute whatever tests requested by the server. Here we see a figure of the setup. We can compare it to the previous example and interpret the one endpoint as the hospital and the other as the ambulance. Tests are pushed from the server, executed between the endpoints, and results are pushed back to the server. Now, adding OpenTAP, a database, and Grafana to the view makes it look like this. We have the same Hawkeye-related setup on the right and the added components on the left. We know what we want to test, specifically the network between the two endpoints. We have the Hawkeye plugin developed, a Postgres database, and a result listener plugin to push the results to the database. And we have also created Grafana dashboard that pulls data from the database and visualizes them as they come in. So we are ready to start composing the test plan. I will now switch to OpenTAP editor and show the process of installing plugins, creating a test plan, configuring test steps, running the test, and presenting the results. Okay, so now we see the OpenTAP desktop editor GUI. We see the test panel in the middle, the steps browser on the left, and the step settings on the right, the log panel in the bottom. So let's just see how we create a simple plan to begin with, and then we move on to creating the actual Hawkeye test that we wanted to later. So on the left, we see we can browse the different steps available. Currently, no specific plugins are installed, so only the basic steps are available, such as delay and different flow control, such as parallel and repeat. So let's just try to add a step. When we drag and drop the delay step, see it's added as the first step in the plan. Selecting it will allow us to edit the settings here on the right. We set that to 1 second. We can also try to add a step called parallel. Now this step, once started, it will run the child steps in parallel. So if we try to drag this delay step up as one of the child steps, okay, and then add another one, maybe a repeat step, and then within that repeat step we will add another delay step. And this one we will also set to 1 second. Now, the plan is now that the parallel will execute all the sub-steps or the immediate child steps as parallel jobs. So beginning with the delay and in parallel running the repeat step. Now this repeat runs for 3 times, where each iteration will run a delay step. So this one should be done in 1 second, and this repeat step should be done in 3 seconds. So let's try to run that. Okay, we are done. Now we can see here the duration of the test step. We can see here what part of the plan that this step was active during the flow. And down here in the log we can see a bit of output. It gives us some output on which steps were run, which steps were completed, which sub-steps were run, and so on, and gives us a summary of the full test in the end. Now here there was no verdict in any of these steps, but if there would be a verdict, they would be green as passed or red as failed, and this would also be indicated down here in the bottom. Okay, so with that initial introduction, then let's open a new plan. I don't want to just save this. Okay, so let's go to the package manager, which we find here in tools. We have the package manager. In the package manager we can see which package we currently have installed, indicated by the blue check mark, and we can see which are additionally available to us. So we start with searching for Hawkeye. It filters the packets and only shows the package relevant to us. You can see if we choose the package, the description of it, and information about what's inside the plugin and what dependency it has. You can also choose which version we want to install. Currently we just select the latest one. Okay, then we also wanted to save the results in the Postgres database. Now we see I've already this plugin installed for supporting both SQLite and Postgres SQL. So that's fine. Now returning to the editor, we can in the test step panel, we can see that the Hawkeye plugin has now been added and the test steps that this provides. So let's try to add an initial step from this. We will add this one called test web service, which tests the connection to the Hawkeye server, and let's try to run it. Oh, I got an error. It tells me that I'm missing a resource. So if I select a step, I can actually see in the setting panel, oh, it requires a Hawkeye server. So this is an instrument. So we go down to the instrument bar, add a new instrument, click the plus. Under the Hawkeye plugin, we will see that the Hawkeye server is available. So let's try to add that. Okay, so we can see here the settings for the Hawkeye server. Currently it's just the URL for the SOAP web service of the server as the only setting that's needed. Okay. Now if we go back to the step, we can try to add it again. Yes, try to run it. And now it's passed. So we see that it got a response from the server, okay. And you can see with the green indication here that the test step has passed. Now, moving on a bit more to what we actually wanted to do. So let's delete this one. We wanted to run a test between 2 endpoints and collect the results. So we can see that there are a number of different test executions available at the moment. This is a work in progress, so more will be added later. So let's try to add a test execution called TCP throughput. Now when adding this, we can see the settings for this. It will require the Hawkeye server. It will require what bitrate you want to try to test the throughput with. It will require you should choose what direction to test. So from the one node to the other, or from this one to this one. It will allow you to select which quality of service to test for. We just leave it at none for the moment. Then it gives you the option to add a tag so that you can find your specific tests in the results in the database later. And you can select the duration of the test. For now we just leave this as it is. But we need to figure out which probes to test from and to. So let's try to see what probes are available on the hardware server. We can do that by using this test step called search for probes. When adding it, we can see, oh, there's something missing. It requires something to put in the name filter, so something to actually search for. This cannot be empty. And even gives a hint saying that percentage sign is a wildcard. Okay, we just want to look for all probes, so we add the percentage sign. We also have another filter option saying whether it should be all probes, only probes that are up, or probes that are down. We need to have active probes, so we select this. Then we can actually right click this and just run this step. In the log we see the output of it. It shows us a list of probes that were found and that are currently up, registered as up in the Hawkeye server. Now specifically the last two, those are the ones I wanted to use. So we can delete this step again and add the probes to this one. Good. So now we are ready to run the test, but we also wanted to collect the results and save them to the database. Now we do this by adding this step called collect execution results and publish. This test step requires to be linked with an execution ID of an executed test. So in this drop down it will list the available execution IDs that are published by previous or by other test steps in the test plan. So we select this one, which is pointing to the actual test execution. So now we are basically ready to run the tests and get the results out. But we haven't set up the results listener yet. So if we go down here in the resource bar in the bottom, we can add a new results listener. Click the plus button, select Postgres SQL, and add the contact information. And with that, we're ready to run the test. You can see the steps in the test plan being started. Now it's waiting for the test execution to finish, such that it can pull the test data from the server. Okay, that succeeded. So it pulled the result from the server and pushed it to the Postgres SQL database. So let's check out the Grafana. You can see the latest result here. And maybe we want to run the test more times, so let's go back to the desktop UI. But actually, I want to run it from the command line interface. Now, in the command line interface, you don't have the options to have this nice overview of the test plan, and you cannot see the different parameters. So, in order to see some of the parameters, we need to expose them as external parameters. So we will do that for bitrate. And save the plan. Now opening the command line, we are in the OpenTAP folder. If we run the executable, we get a list of options. Now we're interested in the run option, so let's use that. Again, we see further options we have for this specific command. Now I want to add the external parameter bitrate and set it to 20 megabit, and on this specific test plan. Again, we see similar output as we had in the log in the desktop UI before. We see the different test steps being executed, and right now we're just waiting for the test execution to finish for the results to be pulled. Okay, so again, successful, pulled the result and pushed it to the database. So let's go to Grafana and check it out. Now we see it got another execution and clocked in at around 20 megabits, which is what we set the bitrate to, so it fits. But if I didn't have the desktop UI available, I could still edit the test plan, but do that from the textual based editor. So let's try that. Again, I go to the command line version of TAP and give it the command TUI. This will open the text-based editor. Here I can open a test plan, so let's open the plan that we have been working on. Now we see the different settings that we have put in, and we can edit it. We can add more steps if we want to. So this concludes the demo. We will now go back to the slideshow. Thank you for your attention. If you have any questions, then please stick around for the Q&A session now.